Okay, so I'm going to start talking about my second module on moderators and mediators. So first, what is a moderator and what's going on? So in this diagram, we can see that our X, which is our main or our primary predictor, causes Y. And we can also see that we have a moderator denoted by the W up there, and it influences the relationship between X and Y, this arrow right here. And it Yeah. So what is moderation? Moderation is how two predictor variables can interact with each other to produce a change in the strength or the directionality of the relationships between the first predictor and the outcome variable. So the best way to visualize the effects of a moderator really is just to kind of look at the numbers. So I decided to run a few models here just to show what a moderated effect looks like. So if I were just to run like a basic model, if I include the interaction of both of our predictors, so x1 and x2. So x1 is going to be our x over here, and x2 is going to be our moderator. We can see that we've got a significant interaction. So this is smaller than the 0.05, it's significant. This happens because the y depends on either x1 or x2, or the combination of x1 and x2. Which is what this moderation is telling us. It says that x1 alone can't predict y, and x2 alone can't predict y. It's the combination of the two that is a significant predictor. So in this case, we can kind of ignore the main effects up here when our interaction, the x1 and x2, is significant, because once we know that this is significant, it's telling us that just x1 or just X2 will not tell us the whole story, since we already know that the interaction between the two is significant. Um, but what if I model, let's see, since we know the interaction is significant, what if I drop the main effects? So this is what I did here. I dropped the main effects and I kept the interaction between the two. So as we can see that the interaction is still significant. That's great. However, we're going to take a look at the R squared. And we can see that it's sort of changed, it's decreased a lot. Now this model is only accounting for about 52% of the variance, whereas our previous model that included the predictors and the interaction covered, 75% of our variance, which this is a big gap. This is a big decrease in our explanation for what's going on. And then now, what if I just look at the additive effects, take away the interaction, and I just look at my predictors? Now they're both significant. So if you're just taking a look at that, that would be great. But then again, the adjusted R squared is much lower. Um, we're missing a lot of the story here. It's, it's important to include the interaction because that can really have a huge effect on the model. So um, that's just what moderating kind of looks like. So more technically speaking, a moderator is a variable that affects the relationship between an independent variable and a dependent variable. It influences the strength or the direction of this relationship. So that's the key. The moderator variable is included in this regression model as an interaction term with an independent variable. If the interaction term is significant, then the moderator variable is considered to be moderating the relationship between the independent variable, the x, and the dependent variable, the y. So this moderation analysis is used to understand when and for whom a particular relationship is, more beneficial, once it's stronger, etc. So the next thing we're going to look at is some actual models. So our first model here, first, I kind of just want to introduce my variables. So my y, my dependent variable, is going to be heart disease. Um, my main predictor, my x1, is going to be body mass index, and then my moderator, or my x2, is going to be smoking. So smoking in this case is going to be used as a binary variable. It's divided into either smoking or non-smoking. The red is the non-smoking and the blue is the smoking. So first and foremost, we're going to look at our coefficients. And we're going to look at our interactions. We see that these p-values are all significant. at the O5 level. So significant moderation effect can be expressed through simple slopes and simple intercepts. So what we're going to do is take a look at a graph. We're going to plot our data and really understand the relationship between the two. Here we can see that our intercepts are significantly different from 0. So when x equals 0 or when the participants don't smoke, it has a different slope than when x equals 1 or when our participants do smoke. In this instance, we can see that the blue line signifies that the patients that smoke appears to have an effect, a stronger effect on the relationship between BMI and heart disease because the slope of the line increases more than, it's got a higher, a bigger slope than the non-smoking does. And we can also see that the interaction is statistically significant, and we can tell using our plots because our slopes vary as well. So this is a nice, pretty clean model. Let's look at another one. So I reran the model with slightly different variables, and here we have a different story. So look at the p-values here. We can see that the interaction between x1 and x5 is not significant at the O5 level. So, but we continue to have our main effects. They're significant as well right here, but our interaction is not. The fact that our intercepts still continue to be significant shows us, we can see that in the plot because the intercepts are significantly different from 0, but then because our interaction is not significant, we can see that the slopes actually don't change. The slopes are the same on these two. Now, so what would happen if we had no significant changes in the intercepts? So then our intercepts would, on this graph, would start at the same place. There would be no change in intercept over here. So yeah, these are just kind of a few examples of moderation in action. We're going to look at mediators and mediation. So what is mediation? So according to David Kenny, mediation is a 4-step process that a mediator or a variable explains the relationship between the other variables, 3 other variables. So our x and our y, so our independent and our dependent variable. When it works, the mediator is mediating the relationship between the independent variable and the dependent variable. When the causal pathway it provides allows the independent variable to influence the dependent variable. It's kind of a mouthful. So what I'm going to do is I'm going to break down David Kenny's 4 steps for mediation. The first one is that we want to show that the causal variable is correlated with the outcome. So we're going to look at this right here. We want to show that the second thing is we want to show that the causal variable is correlated with the mediator. Oops. Sorry. We want to show that the mediator affects the outcome variable. Just be over here. And then we want to establish that the mediator completely mediates the X and Y relationship. So what we're going to do essentially is break down each individual pathway and try to see if it's significant and what that means. So we ascribe a causal pathway between an antecedent and a consequence. So our X antecedent and our Y, our consequence. Our predictors predict our Y, so X is going to predict Y. We want to assess the relationship between the predictor and the dependent variable. So there can be an indirect pathway, causal pathway between the predictor and the criterion. So that would be these pathways here. They're with our mediator. So for X to be able to bring about change in Y, it must act on this other variable, our M, our mediator, before it can act on Y. The causal relationship between X and Y is definitely not straightforward. There are changes in Y. The changes in our Y on X are contingent on the relationship between X and our mediator. It dictates the influence X is going to have on Y through mediation, our mediating variable. To sum it up, in mediation, we want to understand the process by which the predictor and the mediator exist together and understand the relationship. If we fail to rule out mediation, which we'll see an example of, there's or if there's evidence of a mediation effect, that's indicative of the mediator being a better treatment focus. This M is kind of would be closer to the Y than this X here. So this M might be a good place of treatment, kind of depending on what you're studying. So how is mediation different from moderation? Well, a mediator helps to explain the relationship between two variables, while a moderator affects the strength or the relationship between two variables. Barron and Kenny summed it up really nicely when they said that moderator variables specify when certain effects will hold, and mediators speak to how or why such effects happen. So looking at our first model, this one's kind of a classic model, somewhat of a manual method. So our first step is going to be to identify our parameters of interest. So our first parameter of interest, we're going to break it down and we're going to follow this one. This C over here. We want to look at C and we want to see if it's significant or not. The C parameter is going to tell us that there's a significant relationship between our X values or body mass index and our outcome, heart disease. So these numbers are rounded to around 4 decimal places, so they look kind of small. And we can see that this C pathway is significant. So we're going to move on and test the A parameter right over here, the X to the moderator. And we can also see that this one as well is significant. And then testing these two pathways over here, B and C prime, we can see that they are both statistically significant as well. So lastly, what I'm going to do is use the Sobel test to determine whether our mediator significantly mediates the relationship between our X and our Y. So the test is going to calculate the Z-score of the indirect effect, and then it uses the Z-score to calculate the p-value of the indirect effect. So if the p-value is less than 0.05, which in this case it is, we can reject the null hypothesis that the indirect effect is equal to 0, and we can conclude that there is some evidence of mediation. So since our value is much smaller than 0.05, we can reject the null, and the indirect effect is not equal to 0, and we have some evidence of mediation. So that's this model here. And then for the second mediation model, we're going to look at a different method. We're going to use some bootstrapping. So first, what is bootstrapping? It addresses the issues with the Sobel test. According to Preacher and Hayes, the correlation is a necessary but not sufficient condition for claiming the variables are causally related. And the Sobel test suffers a lot from problems related to causality and low power. So we're going to use this bootstrapping method to address some of these issues. Bootstrapping is a resampling procedure. So where you sample at random from your observations and at the same sample size. So usually it's going to be larger than your observations. So looking at the values for the pathways, see here, we're looking at the same pathways as we did before, right? So C, A, B, and C prime. So first is C, the first model, we can see that it's statistically significant. There is a significant relationship between X and Y. Then we're going to look at our B and our C prime pathway. It shows that when the mediator, or stress is going to be our mediator, and heart disease are included in the model, the mediator is not significant at the O5 level. And then the pathway, we see that right here. And then pathway A, we see that this is also not significant at the O5 level. So since our P parameter and our A parameters are not significant, we can rule out mediation in this model because our C prime does remain significant. So we can see here. So when this happens, it suggests that there is no evidence of mediation, as a mediator variable is not influencing the relationship between the independent variable and the dependent variable. However, it's important to note that the absence of significant indirect effects doesn't necessarily mean that there is no relationship between the independent variable and the dependent variable. We can see that here because our C prime is still significant. This pathway between the independent variable and dependent variable is still significant. This might be that the relationship is being mediated by a variable that is not included in this analysis, or that the sample size or statistical power of our analysis is not sufficient enough to detect our effect. So for the most part, testing our data using moderated and mediation tests, we're able to rule out mediation in one of the instances, but not in the other. And then we had some moderated effects in one instance at all levels, and in other instances at just a few different levels. So I guess if it were me and this was the same data that I was using and studying with, I would probably continue to study to try to really understand and get a better picture of what's going on with my data. But yeah, that was it, my mediation and moderation module. Thank you.